Hi students, hello from EdFalco Academy, an epitome of Faro education, which means faster and accurate, affordable and result-oriented education. You can know more about us by visiting our website, either calling us on our contact, etc. Today I'm going to present to you a question from JEE Advanced 2023. It came in paper 2 as question number 9. So since you are now the JEE mains are over, and some of you might have the privilege of participating in JEE Advance, or you might be thinking of giving the JEE Advance, so it will be a good class for you today. And even if not, it's a good thing to know about this topic. Even for a class 12 student, it's important to know about this topic, and this question is it gives a clarity in terms of the electromagnetic field. So be it now or later, this class is anyway going to help you. So let's start and try to understand this question in a very with all the depth. Okay? So now this question is telling that a rectangular coil loop of length 4 centimeter and width 2 centimeter is in XY plane as shown in the figure. So here you can see there is a figure which has a loop which is 4 centimeter in length and 2 centimeter in width. Okay, and it is in the XY plane. So okay, fine, we are clear with that. The next thing is it is being moved away from a thin and long conducting wire along the direction root 3 by 2x plus half y. So this is the, you can say this is the unit vector, right? This is the unit vector which is given along which the direction, along with whose direction this entire coil is being pulled, right, in that direction. And so in general, let us also keep writing whatever we have understood so far from the question. So one thing that we understood was definitely that it's a rectangular coil, and second thing that we are also understanding is that it is being pulled in the unit vector root 3 by 2 along x cap plus half along y cap. So, and how do I know that this is a unit vector? Because if you calculate this, right, I mean root 3 by 2 whole square, if you try to find the magnitude of this vector, you will get 1. So root 3 by 2 square plus 1 by 2, this will come to 3 by 4 plus 1 by 4, right, which comes to 1, right, root over of that, right, the entire thing. So it is root under of 1, which is nothing but 1, and that means it's a unit vector, right, which is just given for showing the direction in which it is moving. And you also know that the angle which with it might be moving. So here if you look at it, this is the y direction and this is my x direction, right? So along this x direction it is going with root 3 by 2. Root 3 by 2 is the magnitude. Okay, so whatever be the velocity, suppose my velocity is v, then in this direction it's going with v root 3 by 2, right? And in this direction it is going with v by 2, right, in the y direction, because the magnitude of this vector, the vector will be represented like what? If suppose v is the absolute magnitude of this particular vector, so v is the absolute magnitude multiplied by the direction of the unit vector. So v root 3 by 2 along x cap plus half along y cap. This is how you are going to write, and that would mean that it is v root 3 by 2 along x cap plus v by 2 along y cap. And that's what I have written here, that it is moving v root 3 by 2 along x direction and v by 2 along y direction. So I hope this is clear about the direction of how it is moving. And it is told that it is moving with a constant value v, so that means our v is basically constant, right? So whatever be the magnitude, but we know that it is going to be a constant number. So fine. Now next thing it is telling is that the wire is carrying a steady current I is equal to 10 ampere in the positive direction, in the positive x direction. So we see that there is a wire, this wire, which is placed at some distance from this entire coil, and it is carrying a current of 10 ampere, and it is the current is flowing in the positive x direction. So fine, that's also given. I mean, it's just for our understanding we have made a direction that okay, top we will call as positive y, right hand side, this side we are going to call as positive x. So it doesn't matter, any direction doesn't matter as such, but we will follow one convention for a problem so that we ourselves don't get confused in which direction it is going. So that's why this is the positive x direction, so we will call that this current is also going in the positive x direction, although the current going in a direction doesn't matter because current is not a vector. Okay, so it doesn't matter whether it's going in the left direction or right direction, but certain things which are produced because of the current, meaning the magnetic field and all, right, they will depend upon in which direction it is going. As such, the current itself doesn't is not a vector quantity. Okay, it says it doesn't require a direction to be specified to show that this much current is flowing. Okay, so having said that, but here let's call it that it's going in the positive x direction. Now, a current of 10 microampere flows through the loop when it is at a distance of d is equal to 4 centimeter. So obviously this is being pulled with a velocity along this direction, right? And because of that, there is a, you know that that there will be a change of flux, because flux is what? Flux is nothing but B into area. B is the magnetic field and A is the area. Now here the good thing to understand is that the current is going in the infinite wire, right? The 10 ampere current. And because of that, there is a magnetic field B which is surrounding the entire the locations around it, right? And just to give you a brief background, I hope you will already be knowing that if suppose there is a current I not flowing, then there will be a magnetic field all around like this, right, pointing like this. There will be a magnetic field, correct? So obviously when we are doing in detail about these chapters, we will study this, but for purpose of solving this problem, we must be aware about, I'm just trying to make you understand certain theories. So the theory basically says that if the current is going, let's say I naught in this direction, and suppose this is my perpendicular plane, right? So so the current is going like this, and this is the perpendicular plane. This is a perpendicular plane. So the direction, if the current is going in this direction, right? By the curling of the finger, you can curl your fingers, or the four fingers of your hand. You can curl in the if you make your thumb point in the direction of the current, whichever be the direction. So in this case, I'm just drawing a very rough figure. If you point your thumb in this direction, your palm is this. Let's say this is your palm. Forgive for my bad drawing, but I think you will understand. And this is your, let's say, your fingers. You pointed your thumb in the direction of the current, and then curl your fingers down, right? So this is the direction of the current, and then I'm curling my all other fingers in this direction, right? So this curling, the direction in which the four fingers are getting curled, right, that is the direction of the magnetic field, and it has to be right hand. Okay, it has to be right hand. So that is the direction in which the magnetic field will prevail. Okay, so you have curled the finger like this, right? So if the current is in this direction, the direction, I don't know whether you are able to see it in the right direction, but just make sure that you have the right hand being used, and your thumb is pointing in the direction of the current, and then you curl your finger, right? So the curling of the finger, whichever direction it is coming, there are only two possibilities, right? Either it can come in a clockwise direction or it can come in an anti-clockwise direction, right, depending on whether you are pointing your finger in this direction or the opposite direction, correct? So the curling, in whatever direction it is happening, that is the direction in which your magnetic field will be present. Now this is about the direction of the magnetic field, but what about the magnitude of the magnetic field? So suppose here the same logic, if I naught is the current and this is my plane, the current is flowing like this I naught, and I know that now my magnetic field will be all around like this, right? Everywhere it will be like this, like a circle all around it, correct? In this way. So the magnetic field B is given as mu naught I by 2 pi r. I naught, basically, because I naught is the current you have assumed. So mu naught, which is the constant of permeability, by 2 pi r. R is basically the distance of, suppose you are looking at this point, the magnetic field will be pointing like this in the direction, in the curling direction, right, tangent to this circle, and it will be at a distance of r. Let me choose a different color. So it is at a distance of r from where the wire is placed. So I hope you already know this formula. So B is equal to mu naught I naught by 2 pi r. Now, because it is depending, it is being inversely proportional to 1 by r, right? It means that as the distance is changing, the magnetic field must be getting weaker and weaker as we go away from the wire, right? So now let's return back to our original question. So this is the magnetic field. We understand that all around this there will be a magnetic field in the space, right? And as the distance is increasing from this wire, the magnetic field must be getting weaker and weaker. So therefore the magnetic field B is decreasing with this distance, right? It is decreasing with distance, decreasing with distance from wire. It's decreasing with distance from the wire, correct? So this much is clear. So that means obviously if you are placing now a coil as we see here, the coil must be having different magnetic field values, right, at a given point. And one more thing is that since this is the wire, the magnetic field is going like this, right, all around. So at a given distance, right, at a given distance, the magnetic field value must be same, right? If it is B over here, and that will just depend on how much it is distant from this wire. The value will be B by B into B is equal to mu naught I by 2 pi r. But it will vary across as I change the distance. So B is definitely changing. Is area changing here? So area is not changing because you are just pulling that entire loop in some direction, right? So the area of the loop is not going to change, but B is changing. And even if you pull it further, again throughout this area itself, the value of the B is going to change. So that means that because of the magnetic field change, or the distribution of this magnetic field in the space, right, the flux um, inside the closed loop, right, is going to change if you are going to pull it, right, in any direction, in the direction that is shown. If we are going to pull it, the flux is going to change. Only the case when it is just getting pulled along the x direction, if this entire wire is just being shifted in the x direction, then there is no change, because whatever. So I hope you understand, but let me just show through a picture. So there is a wire I which is carrying some current I naught, and suppose there is a field, now there is a loop, and now everywhere, right, across this line I told that there is a constant magnetic field in this. And what will be the direction of this? We understand that it will be coming out of the plane of the paper, which means at this point it will be like this is the symbol to show that it is coming out of the plane of paper. This side it is going inside the plane of the paper. The symbol is this circle with a small cross. So everywhere it is going inside, outside, right? In this line it is, again, suppose it is B1, here it is B2, here it is B3, right? So every place it has some magnitude, and it is coming out of the plane of the paper. Now if you imagine that if you move this coil in this direction, then will there be any change in the magnetic in the flux? No, because the area is not getting changed. The distribution of B1, B2, B3 till wherever it is, right, that entire set is also not going to change. The magnetic field is going to remain as it is. Whatever the magnetic field at each of those locations are is not going to change if you are shifting it just parallel to the wire, right? So therefore the B is not changing, the distribution of B is not changing, the area is not changing. Therefore if you are just pulling it in the x direction, there is no change going to happen in the magnetic flux. right? But here it was being driven in this direction, in some direction in between 0 to 90, right? So therefore it will have two components, one going up and the other going this side. We understand the word that the component which is going to move this wire along the x is not going to impact anything. It's not going to produce any current in this wire or any EMF in this wire, because there is no electromagnetic flux change along that direction. But the moment it goes start going up, the component which is driving it in the upper direction, right, that particular um, movement will actually now disturb the entire distribution. Because right now, let's say at this point it has some distribution of the magnetic field. If it shifts up, the magnitude at this all locations will change. Again it shifts up, the magnitude is going to change. So everywhere as it is shifting up, the magnitudes of the distribution is, it will be the magnitude actually will be becoming different at different levels, right? So therefore the flux is going to change. And you now know from Faraday's law that if there is a change in the flux, if the rate of the change of the flux actually defines the EMF that will be produced in that circuit, right? And with the formula is E is equal to minus d phi by dt. If the flux is changing with time, then there will be a EMF produced, and that minus sign is basically coming from the Lenz's law, right? Telling that it will be the EMF will be produced in such a manner that it will lead to the production of a current in the direction, in such a direction that when the induced current or the current which is now coming because of this effect of magnetic field change will try to negate the change that is happening. So if suppose my flux is changing in a particular direction, d phi by dt is changing in particular direction, the EMF will be produced such that it drives the current in such a manner that the flux produced because of that current will. So to get the direction of how on in which direction this d phi by dt is becoming negative, right? So as I already said that here if we look at it here, actually in this particular loop, if you look at it, the magnetic field is basically going is basically coming out of the plane of the paper, right? Is basically coming out of the plane of the paper. Now so that is the direction of the magnetic flux also, right? So here the magnetic flux is actually decreasing, right? The magnetic flux is decreasing. So the magnetic flux, the rate of magnetic flux is actually decreasing. So it is decreasing along which direction? It is decreasing along the out of paper direction, right? So in this direction, which is also the direction of the magnetic flux or the magnetic field, that is the direction where your d phi by dt is becoming negative, right? So this wire, this loop, will try to produce the current in such a manner such that in this direction itself the magnetic flux becomes positive, so that the effect is negated, right? The effect is negated. So now you see that in order to get that flux coming out of the paper to be positive, right? Coming out of the paper to be positive, what is the direction of the current that should flow in this particular loop? Again you can use the same right hand thumb rule, right? What you now need to do is point your finger in the direction of the flux, okay? So you are wanting that your your um, your magnetic flux should increase. You are trying to find the direction of the induced current in this circuit. So you are trying to see that in which direction the flux should be increasing. The flux is going to increase in the direction out of the plane of the paper. So you point your thumb in the direction of in the direction of out of the plane of the paper. So in this direction, okay, which is out of the plane, and then again see the curling of your finger. right? So the curling of the finger this time is going to define the direction of the current. So if you do this activity, you will see that the curling would happen in this direction, right? So if the current is coming out, sorry, if the flux is has to be increased in this direction, the current must flow in this direction, right? To get the to negate this effect of decreasing flux in this direction, right? In the same out of the plane of the paper direction. So this is how you get the um, direction of the induced current. So we have understood the direction of the induced current. We have understood how much of the EMF is generated because of the change in the magnetic field. We have understood change in the magnetic flux. What is magnetic flux? We have understood, right? Why the flux is changing in such a scenario when it is being dragged with some velocity, right, away from this source wire, right, which is carrying I naught current. That also we understood. So pretty much now with all these things we are clear about that there is going to be, so this entire understanding has to go basically at the back of your mind. You don't need to put it on paper. This all need to go at the back of your mind, and this with steps that will go at the back of your mind will help you formulate this question, right? That's the point. So since I am discussing this, I'm discussing in detail by writing it on the paper. When I will be doing this question, I'm not going to write all this story, right? This is all going to be going in the back of my mind. Obviously it will come with practice. It's not like you will do it first time and you will be able to do it on paper itself, in your mind itself. So obviously you will use some rough space and all that, right? But ideally what is expected is it should just the steps should get clear in your mind. And for that you obviously need to be very well aware about the concepts and the theories that are involved in this particular question. So okay, so now we are clear about at least what this question is asking, what is the direction of flux of the induced current and all that, right? Now let's move back to the original question. So yes, so it was moving with a constant velocity v. The wire is we know that it's a 10 ampere wire, and there is a wire which is producing a current of 10 microampere, right? So we have already found out what direction it might be. So it is saying that when the distance is d at the, so it is being pulled, and there will come a point when there is some distance from this longer infinite wire, right? So when that distance d is 4 centimeter from the wire, from the bigger wire, I mean, um, there is a so obviously when it is at a distance of 4 centimeters, telling that the current is 10 microampere. In the induced current in this circuit is 10 microampere. And now since this is a loop, it has some resistance of zero point 0.1 ohm which is given, and this zero point 0.1 ohm is actually able to drive. Otherwise we saw that the formulation says that EMF is equal to minus d phi by dt, right? But where is the current coming from? Current is coming because if you connect that loop, right, if you connect the entire loop and it has some resistance, then obviously the current is going to flow. Otherwise it will be like just like the EMF is generated if it's not connected. If it's not connected, uh, uh, if the path for the flow of the current is not complete, then it's going to be just the EMF. But the moment if we are connecting it there, and there is a resistance, then finite amount of current is going to flow in that circuit, in that loop. So here the resistance is zero point 0.1 ohm. So what is the value that we have to find? We have to find the velocity of this V. So for what value of velocity with which it should be dragged, such that at a distance of 10 centimeter, the current becomes 10 microampere with 0 0.1 ohm as the resistance in this loop, if the current in the original or the infinite wire is 10 ampere, and the direction of the velocity is also given. So now we have pretty much understood all the concepts. So let's now look at the look at the problem of how to solve it. So now you very well understand that there is a need to find out the flux first. the function of the flux, of how it is varying, right? And if I know that, then I can differentiate with time and get the value of the rate of flux change. So here, if you look at it, this is my loop and this is my wire, which is carrying 10 ampere current, right? And yeah, there were certain things also that were given. Let's take a note of that also. It was given that the permeability mu naught is 4 pi into 10 to the power minus 7 Newton per ampere square. Okay, so that's noted. So now since this is flowing, now we know that the magnetic field at all these points, right, they are going to be coming out of the plane of the paper, and their value will be what? V is equal to mu naught into I, which is 10, divided by 2 pi. Let's say here the 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 distance from here to here is, let's say, x. I mean, the point which we are taking, the strip that we are talking about, where we are calculating this, is, let's say, at a distance of x. So 2 pi x, that is the magnetic field that must be prevailing there, right? And if I calculate, and okay, let me draw it a little bit better. So this is my loop, and this is the I current, 10 ampere current which is flowing. And this loop, what I have done is, I have taken at a distance x, I have taken a very small strip which is of length dx. This is at a distance of x. So what will happen? We know that the magnetic field pretty much here is given by B is equal to mu naught into 10 by 2 pi x, based on the formula of that we just saw, and also that all these magnetic fields are coming out of the plane of paper, correct? So now what is going to happen is, if I now try to calculate the flux, right, in only this strip, so let's call it d phi, because the small flux that is prevailing in this particular strip, so it will be given by B into dA. The dA is the area of this strip, and you know that area of this strip will be B into dx into this length, right? Dx is this is looking like a rectangle, right? So with a width of 2 dx, and this would be the length, which is coming how much? It's according to the figure, it was given as 2 centimeter. So this was 2 centimeter, 2 centimeter. So let's call it 2 by 100 of a meter. I'm just for converting it in one SI unit, I'm keeping it in meter. Okay, so now I know that the flux is, oh, sorry, the magnetic field, um, um, uh, sorry, the small flux d phi is nothing but it is B into dx into 0.02, right? And B I have already calculated as mu naught, which is given as 4 pi into 10 to the power minus 7 according to the question, and B is into 10. I'm just taking this value here, whatever is written, divided by 2 pi, divided by 2 pi into x, this is the value of B, multiplied by 0.02 dx. So we understand that everything is now going to be constant, right? So the d phi is being given as pi cancels here. Let's see, whatever cancels, pi cancels here, this cancels to give 2. Okay, so 2 into, we are left with 2 into 10 into 0.02 into 10 to the power minus 7 on the top, and dx upon x, right? So this is how much it would be. 20 20 into 0.02 is so this is 20 into 2 by 100 into 10 to the power minus 7 dx by x, correct? So it will come out how much? This will be 40 into 10 to the power minus 9, right? 40 into 10 to the power minus 9 dx by x, or it can be written as 4 into 10 to the power minus 8 dx by x. So this is the value of my d phi. Now once I calculated d phi, I can integrate it on both the sides to get the entire. So d phi was for just one strip. Now I will integrate it for all such x values so that I get across the entire loop. So then I will integrate this from this 4 into 10 to the power minus 8 dx upon x, and this has to be integrated for the entire value of x, right? So x is varying from where to where. You can see here it will vary from d. Our value was from x we had taken as a distance, right? This was the distance that we had taken. So it has to vary from d to d plus 4, right? It should vary from d to d plus 4. So therefore the value is from d to d plus 4, 4 by 100, just to keep it in everything in the SI units. So now phi flux is given as 4 into 10 to the power minus 4, anyway is a constant. Dx by x integral, you know it is ln of x, and this is equal to from d to, the limits are d to d plus, right? Okay, so now this is 4 into 10 to the power minus 4. Sorry, this is 4 into 10 to the power minus 4 into ln of d plus 0.04 by d, right? Because what will happen, it will become ln of d plus 0.04 minus ln d, and you know that ln a minus b can be written as ln a by b, so I have written it in that way. So now we get 4 into 10 to the power minus 4 ln of 1 plus 0.04 by d. Now just keep in mind that the d value also we must take in meters, right? Because everything we are calculating in meters. We are keeping it in the SI unit. So now we have found an expression for phi, right? And you see that if this flux is depending on the value of d, right? So now if I have to calculate d phi by dt, right? That, because that is what is going to give me the value of the EMF, right? So 4 into 10 to the power minus 4 anyway is constant, and ln of 1 plus 0.04 d. So this is what I need to differentiate. So first I am going to differentiate by chain rule simply. Ln d of this by d of, okay, the variable here is also d and the variable here is also d. Let's call it s, some other variable. Let's call it s, so that we don't get confused. So it is ds, right, into ds by dt, into ds by dt. Okay, so you understand why I changed the variable, because I was getting, if I'm using d, then dd it is coming, right, which might confuse us. So that's why I have just removed that variable and made it s. Okay, so d ln of 1 plus 0.04 by s into d by ds into ds by dt, that's what it will come. So now if I keep on doing the calculation, it will give me 4 into 10 to the power minus 4, and what is d ln of uh, ln of 1 plus 0.04 by s. So we need to calculate this, right? So first I think we will have to do it with respect to so now I have an expression. Now I have an expression of phi. Okay, so now I will do d phi by dt, because that's what is going to give me the value of the flux. So d5 by dt, right? So now here this 4 into 10 to the power minus 4 is a constant. D, we can do this differentiation using the chain rule, so it will be d ln of 1.1 plus 0.04 by s. So I had just changed this value of s. So now I have a function of phi, right? Okay, let's do one more thing. Let's not use d as the variable. Instead, let's call it s. That s is the initial is the distance of that wire from this loop. And why it is? Because when I will try to do the differentiation, it will become d phi by dd. So dd will become confusing. So I just want to get rid of that confusion and just want to call it s variable. There's no big change, right? Any variable you can call it. So I've just called it s. So now we will need to find out d5 by dt, because that is what is going to give me the emf, right? So d5 by dt will become 4 into 10 to the power minus 4, anyway is outside, into ln of, so this I can do using chain rule, right? D ln of 1 plus 0.04 by s by d of 1 plus 0.04 by s first, and then I can do d of 1 plus 0.04 by s by ds, and then ds by dt, right? So I will get the entire thing. Now this ds by dt that you see over here, it's nothing but the S was the distance from this from the wire which was carrying 10 ampere current to the loop, right? That was the value of the S. Now, if suppose S, it is find what will be ds by dt? Ds by dt is nothing but the rate of change with which this is changing. So it is nothing but the velocity component in the y direction. So ds by dt is nothing but the velocity in the y direction, which we had already seen, we had calculated back as v by 2 according to the vector that we were finding out what is the component of that in y direction and x direction, right? So that was coming v by 2, so I will replace that with v by 2 here. So d5 by dt, now it will become 4 into 10 to the power minus 4 into, this thing is going to become 1 by d 1 by 1 plus, it is basically d of d ln x by dx, which is 1 by x, right? So here it will become 1 plus, sorry, 1 plus 0.04 by s, right? Into, now this if I differentiate, it is going to become minus 0.04 by s square, right? So because anyway the differentiation of 1 will become 0, and 0.04 is anyway constant, so it is basically d of 1 by s by ds, right? So d of s to the power minus 1, so that will become minus s to the power minus 2. So it is minus 1 by s square into 0.04, which remains. So this is the entire differentiation of this quantity, and then we have multiplication with v by 2. So this is the overall d5 by dt that I am seeing. So now the EMF that is getting produced will be equal to 4 into 10 to the power minus 4 into 1 by 1 plus 0.04 by s into minus 0.04 by s square into v by 2. This is the overall EMF that is going to be produced. Now EMF, you know, it is nothing but it is equal to Okay, minus of this, right? Because epsilon is equal to minus of d phi by dt. So I will just put minus one more sign here so that I get minus minus cancelled, it becomes plus. So because the formula is E is equal to minus of d phi by dt. So this was d phi by dt. I have just put minus sign also. Now after that, the next step is finding the current, right? The EMF that is induced now, it is going to produce a current I if it is having a resistance R. And how it will be? It will be basically connected by E is equal to IR, right? Ohm's law, right? Because nothing is such as mentioned, so we'll assume that this wire is behaving in a ohmic way, correct? So epsilon, whatever is being produced, is going to be, if it has a resistance R, it's going to produce a current based on the Ohm's principle, which means it will be epsilon is equal to IR, right? So now in this situation, what is I given? I is given as 10 microampere. So 10 into 10 to the power minus 6 into resistance is given as, how much was the resistance given? Let's look at the resistance. It was given as 0.1 ohm. So it was given as 0.1 ohm. So yeah. So this is 1 by 10, right? So overall it means it is coming as 10 to the power minus 6 volt, right? This is current which is in ampere into ohms, which means it will come in volt. So 10 to the power minus 6 volt is the EMF that is getting produced. I will equate this to this, and then what is the question telling? That at S is equal to 4 centimeters. So now when I'm adding 4 centimeter, what will happen to the above equation? Epsilon anyway I have calculated as 10 to the power minus 6. This will become equal to, this minus minus is cancelled to become plus. So 4 into 10 to the power minus 4 into 1 by 1 plus 0.04 by S. S is again 0.04, so it will become 2. Sorry, 1. To cancel out and it will become 1, right? Multiplied by 0.04 by S square. So it will become 1 by 0.04 into V by 2. Now with this I can get the value of V, which is being asked in the question. So let's solve this, and then our work is done. So what we are getting, 10 to the power minus 6 is equal to 4 into 10 to the power minus 4 into 1 by 2 into, this is 100 by 4, and then this is 1 by 2, and then multiply by V. So 2 cancels from this, right? And you see 10 to the power minus 4 and 10 into 100, it will become 10 to the power minus 2 by 4 into V is equal to 10 to the power minus 6, right? Is equal to 10 to the power minus 6. So that means 4 into 10 to the power minus 6 by 10 to the power minus 2 must be the value of V. So I think somewhere we have, just check whether we have done any mistake. So here we were getting 4 into 10 to the power minus 8 dx by x. We integrated it, and suddenly why did we go for 10 to the power minus 4? I think this is a mistake, right? But ln of x, d to d plus 0.04. Okay, I think here there is a mistake. It should have been minus 8. It will carry on as minus 8. It will carry on as minus 8. Okay, so here also it would be minus 8. Here also minus 8. Here also minus 8. This calculation is fine. Is fine. This will be minus 8. This is minus 8, right? So minus 8, and this will become 10 to the power minus 6 then. Okay, and that means this is basically, it went on the other side, so this is also 10 to the power minus 6, and now these two will cancel out, right? So what you get is v is equal to 4 meter per second, correct? And that is your answer, that if it is being pulled with 4 meter per second, that is the magnitude. Then you get whatever is being told in the question. So hope, I think this question was explained in a very detailed manner, right? In a very detailed manner, then we went ahead and we first looked into the problem. Understood that problem in detail. Then we started looking at different theories that were behind it. Okay, and then we looked into each of the theory. I gave a brief background about the theory. Obviously these theories will be explained in more detail as we do it in the classes, but here I have explained it, the theories, uh, in a quick way, so that we can utilize them in our calculations. And then we started with the question. We found out the flux for a given strip. We integrated that and got the entire flux, and then we calculated the overall flux by integrating it. We did some mistake here by taking by 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 wrongly taking minus 4 instead of minus 8. So yeah, these things happen in your exam also. But the thing is that when you analyze something, when you come up with how did I came up that there might be some mistake in this, is when I went down over here, and then this I started getting 10 to the power minus 6 by 10 to the power minus 2, which means I would get 4 into 10 to the power minus 2 meter per second. Now that's a very, sorry, 4 into 10 to the power minus 4 meter per second. So that's a very, very, very small speed. Okay. And it looks very impractical, right? So based on that, you would start again, checking back your answers and see that whether we are doing everything correct or not. So with that, we corrected that, that we had just done a mistake or a typo, you can say, where we ignored minus 4, and we ignored minus 8 and just written minus 4 just by a typo. And then we did found out d phi by dt. We found out the epsilon, the voltage that will be induced, and we calculated with respect to the current, equated that, and finally we got the value of v, which is coming out to 4 meter per second, as per whatever the question was asking. So hope you enjoyed this class, and this class gave you a good idea about electromagnetic field. And obviously when we do it in our normal classes, we will be studying this in more detail. um, so yeah, um, so just to give a brief background about myself, I am a pass out from IIT Madras. My name is Nishant, and I have 14 years of industrial experience and 7 years of teaching experience. So if you want any further information about EdFalco Academy, you can always visit our website. You can call us at any point in time if you have any query, or you can fill our form and we will get back to you. So yes, keep practicing for the advanced. We will come up with more such questions which will help in um, uh, in kind of doing the practice, as well as making you understand in terms of the theory and the concepts that generally go inside framing these questions. So okay, all the best, and keep studying. Thank you.